So continuing on the radicals gravy train, we take a look at this problem here, and you notice that now we've got a fourth root of a fraction. So we're going to have a couple of things that we're going to have to deal with in here. The first thing I'd like you to remember is if we have the yth root, so whatever order of root it is, that's the y's would be a square root, cube root, anything like that, of a to the power of x, that's going to be equal to a to the x over y. So this fractional exponents rule that we discussed in previous skills comes into play here. So we look at this messy looking fraction inside the radical. It's a fourth root, so we're just going to pull that out, that 1 over h, and we're going to remind ourselves that the fourth root of 1 over h is equal to 1 over h to the power of 1 over 4. Okay, that's what the fractional exponent rule tells us. Okay, so this makes things a little bit easier and already starts to make it look like what we're looking for. And the second thing we need to remind ourselves of is if we're really looking for h, and we see we've got 1 over h. So remember the negative exponents rule? That's where you convert between a fraction to a negative exponent. So we can pull out the base h and we get the 1/4 exponent, but because we've got that, we're flipping the fraction, that becomes negative 1/4 now, and this is exactly what we're looking for. We're looking for the exponent of h, d, which is negative 1/4. Okay, so a similar problem to the previous one, except in this particular case we notice that the value we're looking for, d, is part of the fractional exponent that b is raised to. So once again we need to remind ourselves of our fractional exponent rule. The yth root of a to the x is equal to a to the x over y, and we can look at this either way. It's an equation, so it's an equivalency, so we look at it either way. So looking at that radical that we have, the inside 1 over b is of course raised to the power of 1/3 because our root is the third root, the cube root there. So when we look at that, again, the previous question we talked about converting that to a negative exponent so that we can flip that fraction around. Just remind ourselves of that particular rule also. Remind yourself that a to the negative 1 is equal to 1 over a to the positive 1. So that's a way of getting rid of the negative exponent, or bringing it back if you need to, if you've got a fraction. And of course, that 1 could be on the outside instead of the inside instead. So, back to our problem. We're actually looking for, remember, we're looking for d. We're looking for the inside of that fractional exponent, the denominator of it. So we actually have something similar to what we're looking for in b to the negative 1 over 3. Okay, but remind yourself that negative 1 over 3 is equal to 1 over negative 3. And they're interchangeable. You could put the negative sign on the outside, you could put it on top, you could put it on the bottom, so long as there's only one negative sign. And that means that when we're given b to the 1 over d, we know that our denominator needs to be that negative number. So our solution then is b to the 1 over negative 3. And therefore d is equal to negative 3.